Welcome back to this course, and today we are going to discuss some basic thoughts of data science, and especially we are going to see how it can be done using Python. You already learned about basic statistics. You know various ways to calculate, say for example, variance, standard deviation, covariance, and we know that later on these things will be used in machine learning. Moreover, apart from this basic statistics, we will also see we need to know how to handle data, and we want to know how to classify data and maybe perform a simple regression based on the things that we have in hand. So we'll see a simple task that we can do using Python. Before that, I will just give you some introduction to certain types of data and data sets. Okay, let's talk about data set first, data types first, then we'll go to certain data and then we can discuss. So here it is, we have different types of data. So when I talk about data types, I'm not focusing on data types that you see in a computer language, rather the data types in general in statistics, because we always deal with data. Whatever data that you have in hand, whether it's temperature data or pressure data or any other data that you have in hand, it's a numerical data or text data or it's just a signal, an audio signal, a video signal, whatever it is, we should categorize the data. Let's talk about how to categorize some numerical data and other forms of data. For example, if you have a numerical data, it can be of two types, generally speaking. A numerical data may include any value, like it can include what is your IQ rating, or what is your height, what is your weight, blood pressure. It's just a count. It's kind of a quantitative data. It's just a count of numbers, right? So in that case, you have two different types. One is discrete, the other one is continuous. When I talk about discrete data, these data are countable data. For example, you can count number of times you are flipping the coin. Like say 50 times you flip a coin, you count it is 50. And if you want to count how many heads you have in the 50 times, maybe it's again a discrete data. Suppose if a fair coin has a 25 heads, maybe randomly sometimes you get 20, 30, different, it depends. Anyway, it is just a count. On the same way, we do have other ones called continuous data. As the word says, continuous, the things that are changing continuously. Maybe you can think about amount of gas purchased at a gasoline station, or you can think about things that are continuously changing is like time is continuously changing, right? It is continuous. And generally speaking, many analog signals are also continuous signal. We do convert that into a discrete one to manipulate. But generally speaking, other forms of continuous signals can be like you do have examples of how our weight and height changes continuously. It is a kind of continuous data. Then comes the categorical data. So this categorical data represents some form of characteristics such as person's gender, marital status, a hometown, or what type of movie a person likes. It's like a category or categorical data, you could say. And sometimes it's just a small number but this number can indicate something. For example, 1 is for man, 2 is for women, something like that. And these data are sometimes referred as qualitative data. Anyway, these are the simple forms of data that you have in hand. Then you have kind of a mixed data. It's called ordinal data. As you can see, it's a ordinal data. It's kind of a mixture of numerical and categorical data. this data falls into categories, but the number spread or number placed on the category have certain meaning. For example, when you rate a movie from the scale of 0 to 5, maybe 0 has the lowest value, 5 has the highest value, 5 star, right? 0 to 5 star. That's kind of an ordinal data. And at times it can be treated as kind of category where the groups are ordered. When graphs and charts are made, we can see how this kind of data behave. For example, if you survey 100 people and ask them to rate a restaurant on a scale of 0 to 5, take an average of 100 responses. That gives you a clear idea of what is going on, right? Yes. Anyway, that kind of thing is a little bit different. This does not indicate that it is a categorical data, definitely. When you take an average of a response, that gives you an idea of what is the response of people. So that's why we should be careful. It's kind of a reminder that this ordinal data are something a little bit different from that of a categorical data. Well, with this data in mind, let's look at this data set that you have. Here's a data set of car names, car color, age, speed, and the pass, whether the car has a pass or not. Maybe just like a high pass or auto pass, the passes in the highway. Well, right away when you look at this data, you come to know certain things, like for example, the age of the car. When you look at the age of the car, the lowest or the newest car is like 3 years old, and the oldest car is like 15 years old. Coming to the speed, you could see that Ford Black, it tops the speed with 101. Well, we have different models like Hyundai, Kia, Tesla, BMW, Volvo, Ford, Toyota, Volkswagen. All different models are outlined here. Anyway, this is still a small data. So if you have a huge data set like the given part, with this given data, can you predict whether a certain car has a pass or not? For example, if this pass information is not given, or it is given for certain cars, but for one or two cars that you have in hand, you don't have it. So can you train a system so that you can predict for any incoming new car whether this car has a pass or not? That's kind of an interesting feature, right? Anyway, I just want to give you some thought on that, how machine learning can be used for further processing. Anyway, we'll quickly go through some parts here, and I will want to start from the basics of how it can be used. Let's, you know the meaning of mean, median, mode. Mean is the average value, median is the midpoint value, and mode is the most common value that is in use. For example, here we're going to start with these examples that we have in hand. So when you use the Python, we already, maybe you're familiar with what is a NumPy is. Well, a NumPy is a library from Python programming language. So this actually gives a support. It's kind of an added support, especially for multi-dimensional data. When you have multi-dimensional data, it gives a really huge plus to have a NumPy library, because if you want to work with matrices, which has collection of high-level mathematical functions, if you want to operate using arrays, this is a good tool. Well, coming back to this simple code that you have in hand, this code is simply, we are going to import the NumPy, and then we're going to find the mean, the speed. These are the speeds that is given to us, and you want to find the mean speed. So let's simply try this out. Why don't we use okay, here is the Jupyter notebook. Let's try. Okay, so There it is. In fact, we're supposed to get this value done. The value is there. Let's run again. Anyway, so the value you got here is like 79.76 for the mean value. So likewise, you can perform various other operations. If you want to do the median, for example, you can still use the value for median here. Okay, here let's take it as y, and let's print both mean and median. Okay, so the mean and median values are printed. Well, you might have wondering, how about the mode? Yeah, we can do the same for the mode as well. So here it is, but this is a little bit okay, let's do it separately. We are going to use another library there. I will quickly tell you what is that library means. So here it is. So you're going to actually input this SciPy. SciPy is again kind of a free open source Python library, and especially used for mathematical computing and technical computing. So there are a lot of modules in SciPy that can be used for optimization problem, linear algebra, interpolations, and special functions like even signal processing like f of t, fast Fourier transform, ordinary differential equations. These kind of scientific computation you can easily perform using the SciPy, and some of the statistical measures also can be done using this one. So that's how it is done, and we got this results for mode. So it seems that in this given data that you have in hand, 86, right? 86 appears 3 times. Since 86 appears 3 times, mode is nothing but the most common occurrence. So 86 is the most common occurrence, and it occurs 3 times. We got the result. Let's move on and perform few more things. Okay, coming to the standard deviation. Let me quickly get back to you on this. Okay, coming to the standard deviation that you have here. Okay, what is a standard deviation again, in short? Yes, standard deviation is nothing but you want to know how much a value deviates from its mean. So if you want to estimate how much a value deviates from its mean, you consider that as a standard deviation. A lower standard deviation means that most of the numbers are close to the mean, or in other words, close to the average value. The higher standard deviation means that the values are spread out. All the data points that you are having it spread out, or in other words, they are in wide range. You can consider here, for example, if you have the data as, if you consider these are the data that is in hand, you can see that not much variance right here, 86, 87, 88, 86, 87, 85, 86. So these are the data that you have in hand. And if you find a standard deviation for this, it gives you 0.9 as a standard deviation. Rather, on the other hand, if you want to find a standard deviation for this value here, you can see here 32, 101, 111, 138, 28, 59, 77, 97. For this, the standard deviation is 37.8. Okay, what is the significance of it? Just imagine you can take the average value of this. Maybe average value falls around like say 86.5, and then you come to know that all the values, all other values, say 88 is not that far from 86.5, right? Yeah, likewise, that's why when you have a lower standard deviation, which means that almost all the numbers are close to the mean or average value. Rather, if for this one, if you take the average of these numbers, and if you find, say for example, I'm not sure what is the average, but it seems it's more than say 60 or 70, and of course we know that 37 is a little bit far from 60 or 70. Yeah, so that's why you got a higher standard deviation. We can also use the same NumPy library to calculate the standard deviation of the things that you have in hand. Okay, so let's do the same library, NumPy. Here you go. So you got this for 86, 87, 88, 85, 87, 86. This one you have 0.9 as your standard deviation. And let's try for the other one as well. If it is okay. If you okay, let's change it. Just change these values here. So you can have 32 and say 122, 38, 55, 117, 64, 140. Okay, so now we have changed the value, and you can see. Okay, you can also calculate. I think it's better to check what is the mean, and with reference to the mean, let's see what is the standard deviation. So here the mean is 81 and the standard deviation is 40. So that's what we can see from this. If you take individual value like 32, if you take the value 32, 32 is a little bit far from 81, which is your mean or average. Okay, let's move on. Let's talk about a few more points on how it can be done using variance. So you are given with certain values, you find the mean, and this is a general way to find a variance. I don't want to explain everything fully because today's target is not about statistics, it's about seeing how we can use Python to implement some of the machine learning methods. We are step by step, we are drawing closer. But generally speaking, we start from mean, and then you find the difference of the mean, square the difference, average, take the average of all the differences, that's going to be your variance. And if you take the square root of variance, you get the standard deviation. Well, let's directly go here, and we are going to use for variance, let's say Z. Here it is. So you got a value for mean, standard deviation, and the variance. Understand again, like variance and standard deviation are somehow related, right? If you want to find the variance, then you just have to take a square root of standard. In fact, if you want to find the standard deviation, you have to take a square root of variance. So if you take the square root of this 1667.55102, these things, if you take a root, then you will get 40.8356 and so on. Okay, so those are some of the basic statistics. Let's move on and find certain ways to generate random numbers. How do you generate random numbers? Again, you can use NumPy to generate random numbers. So here is the function for us to generate a random number here. Let's say, okay, let me delete this, or let me put it a new place. Okay, here the idea is to generate a random number, but the random numbers are between 0 to 8. So that's what we have, 0 to 8. We want to find the random numbers between 0 to 8. And our idea is again to have how many numbers? Like 500 numbers. So we want to have 500 random numbers, and I want to print out those 500 random numbers. Let's try. Here it is. So these are the 500 random numbers I'm going to have between 0 to 8. They are all float values. You have 500 randomly generated numbers. Yes, sometimes while you operate certain problems, we may have to generate our own data sets or our own random numbers to evaluate. So random number generation is one of the key part of many applications actually. Even for example, if you consider playing dice or playing any cards or playing online games, like people play online, several online games. So even like rolling a die, it's kind of, you should make sure that a randomly generated number should appear. It should not be any number that can be easily predictable. But in truth, there is no pure random numbers. We always have a kind of a pseudo random numbers, because after a millions or even million numbers, something have to repeat again. Anyway, we'll talk about that in another time. We'll proceed with what we have in hand for now. Next is on using the matplotlib library. So here is a simple introduction on how we can use matplotlib library. So here we have this 250 numbers generated, and these numbers are between 0 to 5. And let's say what is going to happen here. Let's see. Okay, so we have generated the numbers, but we didn't print the numbers, rather we have plotted the histogram. Did you notice that? We have plotted the histogram of x, comma 5, and we want to show this plot. So that's what is being plotted here. So let's briefly see what is it. So we just use the array from this particular example to draw the histogram with 5 bars. So that's the 5 bars that we have here. And the first bar represents how many values in the arrays are between 0 and 1. So this is the number of values in 0 and 1, that is the first bar. Then the second bar represents how many values are between 1 and 2, so on. Like the third bar, this is the third bar, represents how many values are there between 2 and 3, etc. So for example, 52, like 52 values are between 0 and 1, and you can say 48 values are between 1 and 2, 49 values are between 2 and 3, 51 values are between 3 and 4, and then 50 values are, okay, so maybe here is 50 values from between 3 and 4. Yeah. So likewise, you can clearly estimate the values by using simple matplotlib library. This a little bit and see what happens. Like we just have the NumPy and matplotlib pyplot. Okay, So generally speaking, when I say matplotlib.plyplot as PLT, which means that whenever I use PLT, it refers to this whole matplotlib. So that's the key idea. Okay, now let's think about generating more random numbers. Say you want to generate, say, like 100,000 random numbers. Let's try a different one here. And let's see how we can plot the histogram in a more different ways. Okay, what we have here is we have 100 bars actually. We are plotted the 100 bars, and all these are the values for 100,000 randomly generated numbers. So that's the key here. So this is different ways to show how things can work out. And one more thing I want to refer is, like, when you have 0 to 5, 0 to 5 is what you have mentioned, right? In this part we have mentioned 0 to 5 as your random numbers. The numbers has to fall between 0 to 5. Rather, here we have mentioned 0 to 8. If you want to change, you can change again. Like, for example, if I want to change here as 8, you can change that as well. So here we have 0 to 8. So among 0 to 8 we have, for example, 0 to 1, you have this much amount among this 250. 250 is the total number. Among 250 you have almost, say, 36 numbers are between 0 and 1, and maybe 55 numbers are between, like, this is like 1 and 2. Yeah. Likewise, you can see they are spread out. In the same fashion, if you want to change this, you can also change to, say, 9, and then, yeah, 0, till 8, and then you have 9. This is the 9th value. So 0 to 9 all been spread out. Okay, we have started looking at how we can use simple plots to explore these datas. Now let's do more on this. Data's being distributed, we often use a distribution called a normal distribution. A normal distribution can really help us to plot things in a more clear way. So it's kind of even you can use the histogram to explicitly point out this normal distribution for different values. Say, for example, here you can also have the random numbers generated, and then you're going to have this kind of histogram which shows you the normal distribution of a graph. Normal distribution is just like a bell curve, because let's say how it looks like here. Yeah, here it is. You can see it's like a bell, right? So this is called the normal distribution. This is like a bell shape, and this bell-shaped curve gives us the characteristics of how things been distributed. Generally talking about probability and statistics, data distributions are normally distributed, or in other words, they sometimes call it as Gaussian data distributions. Yeah, that's one of the basic idea that we use behind this part, and this can be easily plotted using the NumPy and Matplotlib library. That advantage of using NumPy, and we also now come to know about how we can use this Matplotlib library. So using this Matplotlib library, we can also perform many more plots. Like just now we saw histogram, just like a bar chart. And if you want to visualize the same thing or similar stuff using a scattered plot, we can also do it. For example, here X, you have certain datas, and you have Y, certain datas, and in fact you can scatter this whole thing using plot.scatter X comma Y, and you can really show what or how it looks like. So simple way to visualize the datas for XY coordinates. So these datas are not much, You can see we have around like 14 or 15 data points here. And if you want to know how this looks like if you have 100 or 1000 data, yeah, the same function, this one, scatter x comma y, can be used, and it can be performed very easily. This data you can consider any data. For example, this is like age of the car, and this is the speed of the car. So we are just plotting between the speed. Y is the speed, y-axis we have speed, and x-axis we have the age of the car. So now consider many different applications you can think about, right? How many hours you spend to learn data science, and what is your grade? That's another key factor. Or height and weight, you can always plot certain graphs like that. Yes, let's see how this kind of random distributions can happen with other examples as well. Let's see one more part, and here I'm going to have some random numbers generated, and after generating these numbers we are going to plot this one. And again we are going to use this NumPy module in which we want to generate 1000. Here 1000 numbers you are generating for a normal distribution. In fact, you are having two arrays. You are generating x, for one is for x and the other one is for y you are having, and you are going to plot for both x and y. But for the first array, that is x, you have the mean has been set to 5 and with standard deviation 1, whereas for the second the mean is set to 10 and the standard deviation is 2. So with this in hand, we can plot the scattered plot with 1000, right? It's like 1000 plots. Yeah. So you can see these dots are concentrated around the value 5. Did you notice it? Around this value it's concentrated. Yeah. And also on y-axis you can see around the value 10 it is concentrated. Yeah. So when you look at some data, you can see the concentration of the data, as well as you can see how sparsely the outer layer has been spread. It can give us some characteristics of the data that we deal with. It can help us to understand what the data are, how to evaluate these kind of data that you have. Go into some more details on actual machine learning applications. Let's look at one example here. Like we learned about the linear regression, right? So say for example you have a scatter plot, and if you want to find the regression line for this scatter plot, you can also try and see how it works. Okay, let's begin with having this scattered plot first, and you can see there is some kind of trend in this scattered plot, right? If you notice, what is the trend you're looking at here? This scattered plot, it's kind of a decreasing trend. As the number of years increases, the speed decreases. That's the point that you can infer from this particular scattered plot. Now let's see whether we can able to draw this so-called the linear regression line and see how it works. So again, the data are given, and you are going to define the slope, intercept, the values of p, standard error, and statistical linear regression. These parts are defined by means of function, and you're going to return this value, slope times x plus intercept. We already discussed about how what is the equation of the regression line. So we always have the slope times the value of x plus the intercept in its the intercept that intercepts the y-axis, right? So here it is. Let's look at how it looks like. Okay, so this is the actual linear regression line from the basic linear regression equation. We can see the trend line. In other words, this is a trend line that you have here. Well, this again gives us more information of how things can be done. If you want to see what is what, for example, initially you are just importing the some modules that are needed for this particular problem of linear regression. Then you create these two arrays of x and y, that is x and y arrays are created, and you're going to execute the method. Execution method is also needed for us to understand the key values of linear regression. So key values, you know that slope is needed, intercept, these are the two key values that you have to return those. So that's needed, and that's what explained here as well. So when you run, you can see what is happening, right? So the modules in fact take in the values for map my function for x. So each of x array, it goes through this function because x is given as the input. So each axis goes through that array. I mean, each array, each values of x in the array, it goes through this function. And this will result in a new array with the new values for y-axis. And that's where you want to draw the original scatter plot. This is for drawing the scattered plot. And here you're drawing the linear regression model. And finally you are showing it out. That's the final thing. And if you want to see, or if you want to perform, say for example, if you want to perform R square, you can also do the same thing. Like for example, if you want to print R, you can also try printing R. Like yes, this is the R value that we have for this particular problem. So you can see again the R value is like minus 0.7585, which is like nice. It's in minus, right? Negative 0.758, so on and so forth. You can see it's not perfect. In other words, it simply indicates that the linear regression for the future prediction, it's kind of going down. You cannot, of course, predict what is going to happen next. That is one of the advantage of having the linear regression model, right? We always want to predict what is ahead. So in order to predict, for example, if you want to predict what is some of the specific values, we can still use another function. Let's say, okay, so assume that these are the years of the car and these are the speed we have already discussed. So if you want to know like 5 years, 7 years old car, 2 years old car, if you want to know like 5 or 3 years old car, what would be the speed, or 10 years old car, what would be the speed, you can still find it. So we are going to, okay, let me do it again. Here it is. We are going to use, let's take 3 years old car for my function, and I'm going to print the speed for that. Okay, 3-year-old car, the speed is 97.8, or it's almost 98. And if it is, say, do we have 12? Okay, 10 years old car. 10 years old car, the speed is reducing, right? So it is a prediction, 85. How about 20 years? Let's try 20 years. 20 years old car, the speed is 68, as it has reduced a lot. So this kind of prediction that you can have here. And at times these predictions are good, at times it's not good. So we should be careful about this prediction method, which is the best model or best predicted value that you want to analyze those values. In fact, you can also see the trend, how it is going, and based on the trend you can see what is happening with respect to the linear regression. So adding to this, we want to know which is the best fit, or if this is a bad fit or a good fit. We are not sure yet. So we want to see like certain ways to help us to see if there is a bad fit. There may be values that are bad fits. For example, this is a different set of x and y arrays are given to us, and we want to try to fit this model. But when you try to fit the model, in fact, it is a very bad fit. You can see it's almost like a straight line. So when you have such a straight line, this model is not a good model. At times, people also tend to use, say for example, let me put it this way. So for example, if you are using a curve model, maybe this model is more fits than the other model. That's one way of looking at it. This is a quadratic curve. It's kind of a quadratic model that you have, and this straight line is fairly better than the other one, like we saw here. The other one is nothing but this one. This straight line is too bad. Yeah, it doesn't fit, or it doesn't really help us in any way. So if you also want to see its random R values, or if you want to check what happens to the other values of linear regressions, you will notice that it will be very bad. In other words, it has very less values. That's a bad indication of how it is performing. So that's how we evaluate the performance of a linear regression. In fact, let's just see how it can be performed using polynomial values. Polynomial, if you have a curve, just like I have said you, like in this part, if you have really a sharp curve that is going down and up and up and down and then like this, this seems to be a very good fit. This is kind of a polynomial regression. We call it as polynomial regression. It also gives a relationship between x and y. It seems to be the best way to fit all the lines, but it may not be the case for or true for all regression applications. Let's take an example and see how such kind of things would perform in the real time. So here we have a group of numbers, and we are trying to plot this group of numbers as such in a scattered plot. Here we go. Okay, here it is. Can you see that it's decreasing and then it's increasing over this way? So this is kind of a polynomial regression only can fit such a plot. Yeah. So let's try to introduce a simple polynomial model that can fit this model. Let's say, okay, let me simply change this part, or okay, I'll write it as a separate one. And let's use the same thing here. Okay, you're importing the numpys, and we have matplotlib, and finally you're going to have the entire things plotted as such. Okay, so initially we are importing this one, then you are creating the array, you have the numpy methods to make us the polynomial model. As I told you, numpy is useful for many mathematical models. So here numpy is useful for us to create the polynomial model as well. So that's why this part here we have numpy is for plotting this, extracting this polynomial model fit. We are using this numpy. Again, here using this numpy for the line space. We are using the numpy. So here what we are doing is that we are specifying the line will display, or in other words, we start with position 1 and we end with position 22. That is the part explained by this line. Then simply you are plotting this scattered plot for xy, and then after that you are drawing this polynomial regression. That's the final say for here. Okay, let's see how it looks like. Here it is. This is the polynomial regression for the given problem. Yes, so when you have a data set in hand, you can perform simple linear regression. You can also perform quadratic, or you can perform this kind of polynomial linear regression and see whether the data fits to this polynomial regression or not. And in the meantime, you can also see, especially you can check the R-square value. We know the value of R-square, right? R-square is one of the evaluation methods for linear regression. So it is important to know the good relationship that x and y has. If there is no relationship at all, how do we know that this is a better fit or not? Yes, the relationship measure is well established using the so-called R-square. It can give us how strength, or in other words, how much does x and y closer or spread apart, or in other words, how they are related. These stuffs can be explored using it. So this Python really helps us to understand this model. So R square, well, I'm just talking about R square. I think most of you know what an R square is, because you might have come across the linear regression lectures in which we talk about R square. It always falls between the range of 0 and 1, where 0 means no relationship, 1 means 100% relationship or 100% related. So we do use other libraries in, say, Python for evaluating certain performance of such things. For example, scikit-learn. As scikit-learn, let me explain it with this code that we have here. Let's say we have this code here. Okay. So in this code, as we can see here, so this code, we are importing the NumPy library, and then we are performing certain things, like you also take this sklearn, right? So sklearn is like one of the simple methods. I mean, this is one of the simple module that can help us to perform certain programming evaluation. For example, especially evaluating classification, regression, clustering, or support vector missions. So these are some of the things that this package can help us to perform. In generally speaking, those are the core part of machine learning, right? Okay, coming back to this problem here, we are talking about this particular fit. Let's see how it performs. Okay, you have run this. So we want to show what is the actual value that is displayed here. Well, we have this displayed as 0.94. 0.94 is a very good relationship, and we can use polynomial regression for future prediction. That is the idea here. We can use that for future prediction. So let's try to predict now. Let's try to predict some future. Okay. So the information that we have gathered, we can help us to predict the future values. So let us predict a car, speed of the car that passes through certain, say, a toll booth around a certain time. So to do so, we should have a simple this my model. You can input the information for the my model. Let's change this a bit. Let me put it this way here. In fact, let's change it directly here, if you would. Or maybe like we should have Let's keep it as such because we want to know what is this R value. Then let's compare with that. Okay, so we want to check for this 17. What is the values that you have here for 17? And it comes to be the predicted speed is like 88.8733 and so on. So we can check this diagram again, and in the diagram you can see if it is 17, because you can go up and check what is the value, like it's almost yeah, there you are. So there is no dot here initially, but we have predicted a value at this location, right? So that's the key part of linear regression, in this case polynomial regression, that we were able to predict. But the question is again, is this fit really good enough or not? How do we know? Again, can we have a bad fit? Well, this fit is quite good, but it is also possible that we may end up in a very bad fit if we are not using a polynomial regression. Of course, polynomial regression has been used in a best way in this case, as we have seen here in this example. But if you are using a certain line space that doesn't really fit this model, let me delete this. Okay, yeah, line space doesn't fit. For example, we have really shown how things have been working from the beginning, how it is helpful for us to understand and apply linear regression models as well as polynomial regression model. One step further and see what we can do using so-called multiple linear regression. So when I say multiple linear regression, we may have more than one variables are used, especially with regards to determining a certain things. For example, in this examples, we have seen speed of the car and that of the year in which it was made, so on and so forth. And we also discussed a few more points about how this can be used for other applications. So right now let's consider a similar example, the same one about the car. But now let's say if the car has a high power engine, or if the weight of the engine determines the speed of the car, or weight of the car determines the speed of the engine, or does the engine performance determine the CO2 emission by a car. Let's try to predict, for example, CO2 emission of a car based on the size of the engine using this multiple linear regressions. So in this case, we have to import another library. This library is called Pandas. In fact, you might have heard about Pandas, and we will be using this Pandas for data science application in a very wide way. So let me explain one by one. So about multiple linear regression, before we go to that part, I just found that I don't have a data set. I supposed to have a file which is missing. So let's skip that for a while, and I'll come back to that later on. But in the meantime, I also want you to understand there's another library, another software library that is more often used in data science, is especially for Python, is the Pandas, is another library. So this software library, Pandas, so this is specially written for data manipulations and analysis. If you want to perform any data manipulation, for example, even using data frames, we call data frames in Python, as well as various operations related to numerical tables and time series data. If you want to use, you can use the Pandas library. Let's look at one simple example here, where we are going to generate the random numbers again. And you can see when I say numpy as np, which means that whenever I refer np, the numpy is called on, just like before. And again, we are generating, and then we are in this case we are actually performing the plot, scatter plot with means of colors. You can change the colors in a different way, or you can also change the radius actually. If you want, you can change the radius from whatever values that we want to perform. Okay, so let's look at this. Just I want to show you how things are working for this particular applications, and then let's see later on other things related to NumPy as well. To discuss about pandas, so let's skip this. So we'll give another example of pandas. Okay, so pandas have many advantages of using the data frames. So this is one of the basic component of pandas. So we have something called series and data frames. Series are essentially just columns of data, and data frames are kind of array, like in other words, it's kind of multi-dimensional tables that you have with a series of collections of data. So this data frames can be easily manipulated using Python if you have imported the pandas library. That is one of the advantage of using this one. And when we have the so-called data frames from the scratch, if you are building, in fact you're also building something called a dictionary. In other words, it's kind of a values that you have in the database can be saved in the form of so-called the dictionaries. Let's look at this simple example and see how the values are given here, like oranges are given to us and the apples and oranges are given to us as data, and we are going to perform a simple data frame application for the given data of this data are for purchase. Okay, so it has been tabulated right now. You can see how they are tabulated with apples and oranges with this column and row wise. Likewise, you can perform other operations as well. If you want to perform a simple index operation, you can also do that. You just have apples and oranges, you don't know like 0, 1, 2, 3. We can actually provide a simple index for that purchase data frame, like indexes like June, Robert, Lily, and David. So if you do that, our things change a little bit, like it becomes, instead of 0, 1, 2, 3, it becomes June, Robert, Lily, and David. So likewise, in fact, you can also locate a specific customer on particular purchase. For example, in this case, we can check what happens for this particular person, like June. For June, you have 3 apples and 0 oranges, right? So that has been dealt with, and you can actually perform a simple read operation. You are having the data in this particular data frames, and if you're extracting the data using a simple function, simple observation that you got it from it. Import certain files. We can read the files, I said. Yes, we can read files with this import pandas. Then say, I did this simple form here. Here it is. So I'm going to read a file, time series COVID confirmed global cases. So let's see it. So again, as I told you, we have the rows and columns, like we can see from the date, like January 22nd, 23rd till so on the dates. You have the number of cases in different countries have been listed, and if you want, you can actually assign the whole stuff. Let me see whether it is. We could say more, we can take more advantage of having these data frames in hand. Let's call it as say COVID, and this file has to be changed to this file. Oops. Here it is. So I have assigned this COVID variable to this pandas for reading this given file. This file I have in my computer in the directory where we run this Python, and I'm just printing out some header values. And you can also see that you can perform other options, like if I can see COVID.shape and perform this operation. Well, we have error here. Let me see. Yeah, this shape is not a function. So you get the list of the COVIDs. Here we have the 255 rows, 253 rows and 71 columns. So that information's we got it. And moreover, if you want to perform other operations using pandas, for example, let's say you're talking about here we are just using a data frame. I'm going to display the random numbers. Initially, in the past, we used NumPy, and generally we used simple other libraries to randomly generate numbers. But using pandas, you can actually display in multi-dimensional way. Here it is. You have numbers being displayed, right? You can see 0 to 5 numbers with 20, 0 to 19. Here, that is 20 rows and 5 columns. You are displaying this randomly generated numbers. So that's a big thing when we compare it to other methods. So likewise, there are a lot of other applications you can use for using pandas. We will learn more about how we can use pandas in a more better way for performing various data science applications. And to be colorful, you can also make the scattered plot that you learned using matplotlib. When you use matplotlib, you also used random generators, but you can also use different colors to change the whole stuff. As I told you before, okay, this one I already told you, but we didn't run this simple code. Well, when you run this code, you can see what is happening. Like you have this random generated numbers, and again you have an area specified of radius 0 to 20 has been specified, and again all things are being displayed using different colors. So again, it looks appealing. And if you want to display, for example, all other different countries with different values for its GDP, for example, you can do it. Or if you want to know how much car has been sold for a particular company to a different country, it can be displayed using simple diagrams or using the matplotlib. So there are a lot of advantage of using such matplotlib, using pandas and NumPy. We will learn one by one, and this video is a very introductory video where I just introduced how we can use NumPy and matplotlib, again pandas. We will learn how well we can use. There are a lot of deep concepts available which can be used to perform a lot of other things like classification, regression, clustering can be easily performed using such libraries. learned about how to use linear regression, generally speaking, and also you know how to use NumPy and Pandas. So let's go on to a more uh, bigger applications. Let's consider how we can use for classification. For example, let's use this one here. So I'm importing pandas, and then you have sklearn metrics for accuracy score. sklearn again we use for selection for training and testing. We are splitting the data that you have in hand. I'm going to use a file I will show you later, and I will also upload this for your reference. And this file we are going to split into training as well as testing. In the meantime, we also want to import the decision trees classifiers, KNN classifiers. So these are the classifiers we are going to use for us. So this basically we use k-nearest neighbor classifier to, and also we will check how is the accuracy of the entire system as we proceed. So in this case, we are going to use a file that I have here. Let me put this file in the folder first, and you can have this file taken over here. Yes, so that's the daily weather files that you have, and then you can actually have data dot columns. In fact, if you like, you can print the data. So these are the columns. You can see in the columns you have number, air pressure, air temperature, average wind direction. These are the different columns that you have for this data in this CSV file. Then comes okay, let's say you can check what is the data itself. We'll see what is the data that is there, because data variable has been assigned to this part. So here's the data. The data has like 1095 rows and 11 columns. So these are the available things. As you can see here, the numbers, air pressure, air temperature, air wind, and all those informations are kept here, including the humidity. Maybe you can see there are certain things are not needed. If you feel that if you don't need certain things, you can really improve, or you can just delete those stuff. Just to check what are the datas that we have right now. Null datas. So these are the columns that you have here, and in fact this number we don't really need that. We want to classify certain things only with the air pressure or air temperature and humidity. These are the critical information that we are really in need. And if you want to just see the top 5 elements, you can just mention it at data.head. This can give us the needed information that is in the top. So only 5 elements are displayed here. Rather initially it was like 1095 elements. But now let's do a simple task to try to clean the data. So as we know that number is of no use from the earlier inputs that we gave. So let's delete the data that is referred as number. Maybe let's see if there is an error here or what. Okay, it has been deleted, and we have to check whether it's really so or not. Let's say what we have before we had a row. How many rows we had before equals data shape 0. we had 1095 data before, and now we are going to drop using the null drop. You're going to drop some of the data. We are going to drop it. So pandas use this function. This function is from pandas again. The drop now function is from pandas. You're going to drop using this drop now. Once you drop it, then you can see what is going to happen. Like after rows equals data dot shape. Okay, let's okay, here it is. We in fact dropped some unwanted, or in other words, it's kind of cleaning. Simply we cleansed off some of the rows that are using that are of null value. In fact, that is of null value. So we used this pandas drop now function to do that. And you can see that difference is almost 31, right? We have the 31 as your difference. So now let's try to classify certain tasks. You want to see, say for example, humidity between like certain period of time, relative humidity for a particular period of time. Maybe you have period of time is given here, 9 a.m. and also 3 a.m. is given. So let's take relative humidity at 3 a.m. for example. Okay, let's clean data equals data dot copy, and again clean data for high humidity. Let's call clean data. That is the relative humidity. At 3 p.m. that is greater than say 24.99. High humidity label. Let's see whether we have some error. No. So let's proceed and see what is happening here at this point. In fact, we can name that high humidity labels were given to us from 0 to 1094. That was the original data that we have in hand. And let's consider this as y equals clean data high humidity use the copy function, then clean, just copy it, Okay, so that's the relative humidity we got for 3 p.m. and we can use this Y header. Y has been assigned for the clean data for high humidity, so let's take Y header. Okay, that's also given here for us. These are labeled between 0 and 1, and let's see whether we can predict the humidity in the afternoon at 3 o'clock or 3 p.m. with the information that you have in the morning, that is 9 a.m. So we'll use the morning features as our input to determine what is the. So morning features is we have air pressure at 9 a.m., air temperature at 9 a.m., like rain accumulation, wind speed, all informations are given to us in the morning, and we can use this morning features to try to predict what is going to be the humidity at 3 p.m. So let's have another variable x for this clean data morning features. Okay, just the way we did for y, we are doing for x. So we know that x columns and y columns. Okay, so this is one simple error that we got. Error, like at times I do make a typo error, like for example clean, I have said cleared. That may be an error. Yeah, here it is. You have the index as high label, and if you want to see the x as such, x dot column, you can also check it out. Yeah, x, these are the things that you have in hand. So you can simply perform some tasks to have the values as training and testing, and then you finally perform simple analysis. Let's say x train comma x test comma y train y test, that's equals to train test split x comma y comma test size. Let's put a size as say let's say 28% of that goes there, and random state, say let's say 250 or 320. Okay, you can perform such analysis using any data that you have in hand. So in this case we just use the humidity weather informations, in which we just try to find the humidity of weather in the afternoon based on what you have in the morning. We know that we are using decision tree classifiers. It is also good if you could use certain visualization along the way. Here in this part I'm not using any visualization, so if I recommend that it is good to use visualization along the way. Okay, so decision trees criteria are put up here. So at this point I also like to emphasize that in fact the decision tree classifiers specifically we didn't learn much on that. So at this point, any point of time, we like to always see what is the prediction error or what is the accuracy measures of any classifier. So we always like to see whether the prediction is correct or wrong and check its accuracy. So that's what we are also going to do here. So basically these features that we have for any given classifiers, these are the main parts like prediction and accuracy, precisions, and in other cases we also talk about sensitivity of a system. So if you recall the so-called confusion matrix, they are also useful analysis that you can perform. Okay, so with this we can put for 10 values. Array, so we got 10 values in arrays for Y test. Again we can take for 10 values. So these are the 10 values for which falls between zeros and 1, and we want to measure the accuracy. This is the prediction that we got for a humidity classifier based on the morning information that we have in hand, morning features. We use the morning features to use the decision classifier to make the prediction, and the prediction falls as such. Now we want to know how do we measure the actual accuracy of this case. So true value should be equal to the test value, and prediction values we have to check. Okay, let's turn this. Okay, so accuracy is a little bit like 77% accuracy is not that great, but we do got this accuracy as per the information that we have in hand. But if you split this values, let's split this value in a different way, because we have splitting the testing and training, because if you have more training then maybe the accuracy might be better. That's another way to say it. Let's say I'm having this as 40, and let's say what happens if that is the case. Here let's run this. In fact I can just put shift enter. Well, it doesn't. There is the values of inconsistent values are available. Let's say a simple measure can change the whole thing. Okay, so anyway, let's stop for a while. Anyway, the point that I want to emphasize here is that, of course, our prediction accuracy was initially that we saw here was 77%. Let's see what is the percentage that we had. Is like prediction is just 77%, and this case we have an error. Okay, I don't want to spend much time on debugging right now, especially. Only point is, let's say I have like 40, then I run this off and I run this off, and then I run this here. Okay, it's different values, 78.78. Let's change. Whenever you make certain changes to the values in hand, they may reflect upon your accuracy, because you are using the test, and now it has increased to 82%. So randomly, anyway, whenever you see which is the exact amount of things to be split for test and training is also an important factor. Always the better is that the more you have for training is better, so that your accuracy will increase more and more. Yeah, so they are varying in this whole factors. So when you change the given data that you have in hand, along with all other stuff that is in place, the equally splitting is very essential. So in this case, we have changed to evenly, we are spaced, both are evenly spaced, so we expect that accuracy might increase. Yes, it increasing to 81%. Well, that's how we are going to perform. The same idea, the same method you can use to perform for KNN. KNN classifiers are simple classifiers, and this KNN classifiers can also be used for classifying the data that the same way we did for using decision trees. So at this point, I like to stop here, and I think today we learned a lot about all different parts on how we can use simple Python libraries to perform some analysis. But I think it is also good if I can give you a concrete example of theory and practical session side by side. That would be better, I think, because this process might be a little bit fuzzy, because especially I teach a theory separately and I'm doing this practice over here. So anyway, we'll stop here, and when we come back next time, we will get into more details on how we can perform machine learning programming using Python and other libraries that we have in Python. So let's stop here for a while.